Hey everyone, and welcome to today's Explainer. If you've ever looked at modern enterprise security infrastructure and felt like you're literally drowning in an alphabet soup of acronyms, AD, LDAP, SSO, OIDC, JWT, yeah, you are in exactly the right place. Today, we're going to completely demystify identity and access management, IAM for short, and trace its evolution all the way to the holy grail of modern security, zero trust. All right, let's dive right in. So to really understand the solution, we first kind of have to wrap our heads around the sheer scale of the problem. Picture a tiny startup, right? Like 20 employees. Everyone creating their own separate accounts for each application is completely fine. But what happens when you scale that up to a massive enterprise? Think 20,000 employees. Now, picture hundreds of different application systems spread across hybrid clouds, on-premise servers, AWS, Azure, Kubernetes, SaaS platforms, VPNs, GitLab, ERPs, and CRMs. If every single one of those systems requires a unique username and password, man, you've got an absolute IT nightmare on your hands. We're talking monitors completely plastered in a chaotic mess of sticky notes with passwords scribbled all over them. So, here is how we're going to logically break this all down today. First, the IAM challenge. Second, the core capabilities of IAM. Third, authentication and SSO. Fourth, authorization and tokens. And finally, zero trust architecture. Okay, kicking things off with Section 1, the IAM challenge, looking at identity at scale. Now, the true danger of poor identity management is this sort of snowball cascading effect. When you have hundreds of isolated systems, users are inevitably going to suffer from password fatigue. They just forget their logins. And your IT personnel, they get completely overwhelmed trying to manage all these decentralized accounts. But here's where it gets genuinely scary. When an employee leaves the company, someone inevitably forgets to deactivate their account on, say, system number 47. That lingering access is a ticking time bomb, because without centralized identity, excessive privileges basically invite what we call lateral movement attacks. That's a severe security risk where a compromised account can just hop horizontally from one internal system to another, completely unchecked. No way you want that. Moving right along to Section 2, core capabilities of IAM, the foundational pillars. You see, to solve all this chaos, IAM isn't just a simple login screen. It's really about the complete lifecycle management of a digital identity. And it's built on four absolutely crucial foundational pillars. Pillar 1 is identity. Who exactly is the user? Are they an employee, a partner, a customer, maybe even an API? Pillar 2 is authentication. How do you actually prove you are who you say you are? Pillar 3 is authorization. Okay, you're in, but what exactly are you allowed to do? Can you just read a file, or can you modify and delete the whole shebang? And finally, Pillar 4 is audit. Who did what and at what exact time? So to anchor that very first pillar, identity, enterprises need one centralized repository to manage everybody. The most common foundational step here is LDAP, which stands for Lightweight Directory Access Protocol, and Microsoft's Active Directory, or AD. AD actually builds on LDAP and integrates things like Kerberos, group policy, and DNS right within a Windows domain. The huge takeaway here is that instead of having all these scattered, orphaned accounts, the enterprise unifies all employee accounts, departments, groups, emails, and job titles into one single managed place. It becomes your single source of truth. All right, Section 3, authentication and SSO, proving user identity. So authentication fundamentally asks, are you really you? And let's be real, passwords alone just don't cut it anymore. Enterprises drastically reduce the risk of stolen credentials by enforcing multi-factor authentication, or MFA. MFA is great because it requires verification across distinct categories. It combines something you know, like a password or a PIN, with something you have, like a one-time passcode on your phone or a physical security key, and increasingly something you are, like a fingerprint, facial recognition, or an iris scan. But, obviously, we don't want users jumping through heavy MFA hoops every single time they click on a new app. It's just too much friction. This is where single sign-on, or SSO, is a total game changer. Imagine your company has an ERP, a CRM, an HR system, GitLab, Jira, and Kubernetes dashboards. Having to log into each one individually, terrible user experience. SSO lets you log in securely just once. After that initial verified login, boom, you are instantly granted access to all those other enterprise applications. It completely transforms the user experience, wipes out password fatigue, centralizes login management, and, as a huge bonus, significantly lowers the workload on your IT help desk. Which brings us to Section 4,
authorization and tokens, or strict access control.
Now, here is where we hit two terms that confuse almost everyone. Seriously, they get mixed up all the time. OAuth 2 and OpenID Connect, or OIDC. Let's clear this up once and for all. OAuth 2 is purely for authorization. Think of it like allowing a third-party app to access a specific folder in your Google Drive without ever giving that app your actual Google password. It simply delegates access rights. OIDC, on the flip side, is actually built directly on top of OAuth 2, but it adds this crucial extra layer of proving who the user actually is by returning a login identity token and user information. To put it simply, OIDC equals OAuth 2 plus authentication. Today, OIDC is pretty much the gold standard protocol for modern cloud apps.
So, once that OIDC login is successful, how does the system actually remember you as you click around? Well, it definitely doesn't query the main database every single time you click a button. That would literally crash the system. Instead, it issues a JWT, a JSON Web Token. You can think of a JWT as a short-lived digital ID badge. It holds your user ID, username, role, and expiration time, and the issuer's signature. You basically carry this digital badge with you for every subsequent API call you make, and an API gateway rapidly validates it on the fly. It radically improves system performance.
Okay, so your token proves you're logged in, but what permissions does your shiny new badge actually grant you? There are two mainstream models for this. First up is RBAC, Role-Based Access Control, where your permissions are fixed by your job title. Like a network engineer gets one set of fixed rights, while an HR rep gets another. Pretty straightforward. But what if that HR rep is logging in from an unknown device in a foreign country at 3 a.m.? Yeah, that's where ABAC comes into play. Attribute-based access control. ABAC grants dynamic permissions based on multiple attributes: your department, your location, time of day, device security level, and even your IP address. Because of this dynamic flexibility, ABAC is absolutely the necessary standard for large, complex, global enterprises today. Finally, Section 5, Zero Trust Architecture. Never trust, always verify. Zero trust really represents a complete mindset shift in the industry. Back in the day, companies built digital moats. If you were inside the corporate network, you were automatically trusted. Well, in a zero trust model, that old concept of a safe internal network is completely dead. The core mantra is simple: never trust, always verify. Every single access attempt is rigorously scrutinized, no matter what. The system continuously checks your user identity, whether your device is trusted, if there's an IP anomaly, if your geographic location actually makes sense, and if you've completed MFA. All these tools we've talked about, IAM isn't just a little piece of zero trust. It is the absolute core engine that makes zero trust even possible. So let's see how all these puzzle pieces fit together into one cohesive flow. Here is the ultimate anatomy of an enterprise login, pulled straight from the architect's notes. Let's follow the journey. The employee opens their browser and hits the SSO portal. That portal checks the identity provider, like AD or LDAP, and demands MFA validation. Once you're verified, OIDC handles the authentication, and a JWT token is issued to the user. From that exact moment on, every single action the user takes passes through an API gateway, which validates the token and enforces those RBAC or ABAC rules we talked about, before finally allowing access to the application and the underlying database. It's just a beautifully logical, secure journey from your keyboard all the way to the data. So if you're the one actually designing a system like this, what are the core architect best practices we can pull from these notes? Number 1, centralize all accounts. You've got to eliminate those isolated orphan accounts immediately. Number 2, enable MFA comprehensively across the board, no exceptions. Number 3, use SSO to reduce password management costs and rely on OAuth 2 and OIDC as your modern application standards. Number 4, use short-lived tokens like JWTs for your APIs. Number 5, ruthlessly enforce the principle of least privilege and routinely clean up idle accounts. And lastly, never forget that audit pillar we mentioned earlier. You need to establish complete audit logs to make compliance and seamlessly integrate your IAM with your broader security ecosystem. I want to wrap things up today with this incredibly powerful statement straight from the architect's notes we've been analyzing. In modern enterprises, the network boundary is no longer the most important defense line. The real security perimeter is identity. If you can properly manage every single identity, every authentication attempt, and every authorization right, you drastically reduce your enterprise's attack surface. It leaves us with a pretty provocative thought to ponder. If identity really is the new firewall, just how secure is the digital identity you're logging in with right now? Thank you so much for joining me on this explainer, and keep exploring.